Hey everyone, and welcome to the channel. My name is Tyler Kenna, and today I'd like to introduce a new project that I've been working on for about a month and a half here called OddDotNet. OddDotNet is an open telemetry test harness that works for any language. Now, before we get into the details of OddDotNet, how it works, and how it can help you with your projects, I think it's important to review some of the fundamentals. I'd like to give a high-level overview of some of the concepts that it deals with without going into too much detail before we get into a sample application and a demo. The first concept that we have here relates to observability. Now, what is observability? I took some quotes from a couple different sites here just to give an idea of how this is explained. Observability lets you understand a system from the outside by letting you ask questions about that system without knowing its inner workings. That comes from the OpenTelemetry website. And also, Charity Majors, who's the CTO over at Honeycomb, in a blog post mentioned that observability means you can understand how your systems are working on the inside just by asking questions from outside. Now, within observability, there are what's called the pillars of observability, and these are logs, traces, and metrics. These three pillars of observability also tie directly into OpenTelemetry. OpenTelemetry then is an open standard that enables observability. It defines standard formats for these three pillars, the logs, traces, and metrics. And then it also provides a number of APIs, SDKs, and tools that you can use in order to instrument your applications and set them up so that they export telemetry data to a telemetry backend. And lastly, with those two concepts, I also want to go over a term that's referred to as observability driven development, or ODD. In fact, that's where Odd.NET gets its name. ODD advocates shifting left the verification and validation of telemetry signals. And up to this point, observability driven development has traditionally been a manual process. It's involved building your application, writing all of your tests and everything required to deliver on the product, deploying your application to a dev environment or a staging environment and running it, and then checking your observability vendor backend to see if it's received all of the telemetry signals that it needs to and if they all look correct. Now, in order to show why I believe observability driven development should be a part of just everyday software development, I'd like to give an example that deals with missing telemetry signals during a production outage. This is a situation I've run across this personally. I imagine many of you who are watching have encountered similar situations. A production outage occurs, and the very first thing that you do is you go look at the telemetry data to determine what went wrong, what the problem is. On numerous occasions, I've tried to do that myself, and I found that we didn't have enough telemetry data to be able to determine the root cause of the problem. And so what we ended up having to do was go back to the application, the source code, add some more logging, add some more steps in place to determine what the flow of the logic was through the system, redeploy that code and let it run, and then go look at the log messages to determine what happened. Now, confirming that those telemetry signals are there at the end of the development process after this application has already been, deployed to staging, for example, that results in a very poor feedback loop. You don't find out that you don't have the right signals until it's too late when you need those signals to be available. And on the OpenTelemetry website, again, they have a quote that I liked. They said, an application is properly instrumented when developers don't need to add more instrumentation to troubleshoot an issue because they have all of the information they need. Observability then and observability-driven development should be part of the development process from the beginning. Now, currently, observability-driven development is traditionally a manual process. The idea is a developer writes some code, runs that code, makes sure that it's generating the correct signals, and then checks whatever telemetry tool they happen to be using to verify that those signals are present, that the correct telemetry data was generated. The issue with this approach, other than it being manual, of course, is that there's no easy way to automate the verification and validation of telemetry signals. And then there's also no easy way to guarantee that those signals remain present across code changes. As an example, let's imagine that a log message is being used to generate an alert. If we remove that log message, we may affect operations further up in the or further down in the process, I should say, right of the process, that may depend on those signals being generated. So how do we solve this problem? We solve that problem by using OddDotNet. That's where OddDotNet comes in. OddDotNet aims to simplify the process of verifying and validating telemetry in an automated way. And what it is a container image that you can run with Docker or Podman. This container image has an OTLP receiver, an OpenTelemetry OTLP receiver that can accept traces, logs, and metrics, currently just traces. And then it also provides query capabilities to verify and validate that telemetry data. Now you can find OddDotNet under the OddDotNet GitHub organization. There's a number of repos you'll notice if you go take a look there. The first one, of course, is the main OddDotNet repository. This repository is the one that manages the container for accepting telemetry signals and enabling queries. There's also the odd.proto repository. This is where all the protobuf files live for communicating with odd.net. There's odd.c#, which is a C# NuGet package that includes a query builder for communicating with odd.net. And then there is an odd.docs repository. That one you don't need to worry about. That's just where I keep the documentation. I have the website listed here in the PowerPoint, and I'll also put it in the description below. I'm not a website designer. I'm just using Jekyll. So bear with me as I try to make the site look a little bit better than it is. I also have odd.java, which is planned, and odd.go. Both of those are planned packages that I intend to create soon. And then lastly, you'll see a repository in there. Currently, there's just sample aspire to do app. I plan on having other sample repositories. The idea behind each one of these is it will demo a specific piece of functionality that odd.net provides. So with that brief summary overview, I think it's time to dive into the demo application itself. The demo that I have for today, you can find it on the odd.docs website. I'll put the link below. There is a C# .NET Aspire page here. And .NET Aspire, for those who aren't familiar with this is just a tool for helping you build distributed applications. Enables you to spin up things like containers that your application might depend on so that you can make sure everything is working together. So the application is called Aspire to Do app. And the Aspire to Do app, I'll pull up the code in just a minute here. I'm just going to walk over the summary first. It's just a very simple application with the ability, it's a web API that provides you with the ability to create to-do items with a title and a description, and then retrieve those same to-do items from the database using their ID. Now requests, the important part here is that requests to retrieve the same to-do item are cached for 30 seconds. And so we're going to use observability-driven development and the telemetry signals that the application is producing to make sure that our application is behaving how we expect it to, and that the way we expect it to behave is the same as the way that the telemetry signals are describing that application as behaving. And before we continue, I want to give credit where credit is due. There's a repository that I've got over here on the other tab. This is the to-do-odd repository. This sample project and some of the odd.net work that I've done was inspired by a talk given by Martin Thwaites at the NDC London 2023 conference, where he talked about observability-driven development and how you could automate that process and write tests around your telemetry signals. So his application is doing essentially the same thing, creating to-do items, and then when those items are requested, they're added to cache. And then he has some observability-driven development tests down here. Two important tests. The first one is he's saying get to-dos with cache data does not call the database. And so in this test, he's making sure that the span that was produced that indicates that the database was called, that span isn't present in the telemetry data that was generated. And then in these other tests, this V3 one, for example, the first call does call the database. That's confirming that span shows up. So with this context, let's take a look at the odd.net sample project and see how that works. Okay, so this is the sample project. As you can see, I have it broken up into two directories. There's the source directory and then the test directory. Let me walk through all of the different project types first and how they work, and then we'll get into how the test itself works. The first project we see is this to-do app host. This is a .NET Aspire project. This is for building distributed applications, as I had mentioned just a few minutes ago. I specify the single project, which is the to-do web app project, that it should spin that project up and provide me with the dashboards and everything that comes out of the box. In just a minute, I'll show you how the project works without the test so you can see what data is being generated and how we're accessing things. In addition to that, there's the service defaults project, the to-do service defaults. This one can mostly be ignored. This project is just used for setting up things like OpenTelemetry and making sure that it's exporting the signals to the correct place. The last one is the to-do web app. This is the actual application that we're writing that's performing business logic. And let's walk through this one real quick. First, there's a database. This database in the setup code is just a SQLite database. I called it SQLite.db. This is just for storing the to-do items temporarily. And then there's also memory cache that's being used. So I add the memory cache right here. And memory cache is when the request is made for a to-do item by an ID, that item is then added to the memory cache for 30 seconds so that if the request is made again, it'll hit the cache instead of the database. We can see that logic right here if we look at the to-dos controller. In the to-dos controller, we have two routes. The first route is the create to-do item, which just lets you pass in a request and you get the response back with the to-do ID. The next one is give me that item, that to-do item, using that ID. And you'll notice the important part here is the first thing we do is check to see if the item is in cache before we hit the database. If the item is not in cache, then we go look the item up from the database. We set the cache for 30 seconds with the item that we found, and then we return that item back. Fairly simple application. Now let's get into the test projects. The first test project is the to-do test app host. This is almost identical to the regular to-do app host. The only difference being that rather than just spin up the project that we need, we're also spinning up a container. And in this instance, the container is the OddDotNet container pulled from the GitHub container registry. In addition, we're exposing target port 4317 for the container. We're calling that gRPC. We're also exposing port 4318, which is our HTTP port. This right now is just for the health check endpoint. HTTP functionality is not yet supported. Once we've created that container, we grab the gRPC endpoint and we instruct our web app using this environment variable, the OTLP environment variable, to export our traces to the endpoint that we defined for the container. If you are downloading this repository on your own and plan on trying things out, the to-do test app host is not intended to be run on its own because we're modifying the way OpenTelemetry, for example, is being set up. The dashboard isn't going to work as well. So if you just want to run the application on its own, run the to-do app host. Otherwise, just use the tests in order to run the automated tests. So lastly, we have this to-do test section. And it has a single test in here called get to do should. And we're going to dive right into how this works. But before we do that, let's take a look at the running application and just get an idea of how it behaves. So I'm going to come up here to our to-do app host. Actually, I'm going to come up here. We've got the HTTP. I'm going to go ahead and set it running. Let me pull up the browser so that you can see that display instead. Give me just a minute here. That up. Okay, so in the browser, we can see we have a single running application. That's our to-do project. We can take a look at the raw logs that are coming from the project if we want to see that. You can also look at those logs as structured logs if they're coming in that way. You can take a look at metrics. You can take a look at traces. And you can go look at additional information related to this project as well. Now, if we take a look at the Swagger page, you'll see there's two endpoints that we have defined. The first endpoint is a post to create a to-do, and the second endpoint is just to get that same to-do by ID. So let's go ahead and test this out, and we're going to take a look at the traces so that we can get an idea of what the traces are describing, how the traces are describing the behavior of the application. And try this out. Let's just do test for that. 1, 2, 3 for the description. We'll go ahead and execute that. You'll notice we get a 200 back. I wipe out the database every single time with this project, every time it starts up. So we restart at ID 1 for this, just as a demo application. So we're going to take that one ID, and I'm going to come down here and try this one out and say, give me that test. We're going to execute that. You'll see I get a 200 back, which includes the same information. And then if I execute it a second time, nothing different. I don't know why we would expect anything different. We get a 200 back again. If we go look at the traces, though, this is where things start getting interesting. On the traces page, you can see this first get right here. Sorry, let's take a look at this one. This post to-dos right here. This is where we create the to-do item. And you can see in this section right here, this child span. This child span is actually the thing that's writing to the database. If we take a look at the instrumentation details associated with this span, you can see that the instrumentation scope source was OpenTelemetry.instrumentation.entity framework core. If you're unfamiliar with C# or the .NET ecosystem, Entity Framework Core is an ORM, just a database context. You can also see what version of the instrumentation scope was used. In addition to that, you have information about the resource that generated the span. In this particular case, the name of the resource is to-do. You have all of this additional telemetry information as well. And all of these details that you're seeing here, these are all OpenTelemetry attributes that have been added to the span to give you more information about that particular step in the workflow. So we can see when we posted the to-do, it hit the endpoint, that's this first span here. The next step in the process was go call the database, insert that record into the database, and then return. Not super interesting. It's more interesting when we take a look at requesting that same information later on. The first time that we requested this to do by ID, you can see that it lists two spans, two total spans. The first span, again, is just the request to the endpoint. And the second span, if we take a look, again is OpenTelemetry.instrumentation.entity framework core. So we know just by the spans that were generated that when we made a request to this endpoint, the database was hit. Now, if we take a look at the second request, you'll see there's only a single span in here. That's because on this second request, there was no database hit. It used the to-do item that was already in cache and returned that rather than hit the database. So using telemetry signals, we're able to confirm that our application is behaving and doing all of the things that we expect it to do when we expect it to do those. Now, how would you automate this? The process that we just did right now was looking at was performing observability-driven development, where we went and looked at the actual telemetry data that was being generated, but we did it manually. We had to go check this dashboard or whatever OpenTelemetry tool you happen to be using and make sure that the correct spans are present and that incorrect spans are not present. That's not necessarily an ideal scenario, and it's very brittle. So a different approach to this is using OddDotNet. And like I mentioned earlier, OddDotNet is a container that you can run that acts as an OpenTelemetry collector. So it receives your telemetry signals, and then it provides a query service that allows you to query the collector and say, did you receive this signal, or give me all of the signals associated with this trace. So let's take a look at the sample code, the sample test, and see how we tested this same thing in an automated fashion. 1 second here to switch over to that window. This is my first time doing YouTube videos and recording anything on the screen, so bear with me as I go through the growing pains here. Okay, so here's the test project. Let's go ahead and do a walkthrough of how everything works here. So inside the test project, you'll see there's that getToDoShould class, and there's a single method. So getToDo should use cache on second request. So we're going to verify programmatically using the telemetry signals that the first time we make a request to this to-do endpoint, that we hit the database, and the second time we make a request to the endpoint, that the cache is used. The first step in the process, we create a to-do item. We send that to-do item to the endpoint, and we make sure we got the success status code back. We need the ID from the new to-do item, and so we parse that ID out from the model. And then the next thing that we do is we create two trace IDs and span IDs for the trace parent header. Now, if you're unfamiliar with OpenTelemetry, OpenTelemetry has a header called trace parent that you can include in your HTTP requests. The format of that header is 00 dash the trace ID dash the span ID dash 01. And trace ID is a 16-byte array, span ID is a 8-byte array. The idea here is that you can pass in your own trace ID in the header as part of an HTTP request, so that when your application receives the request, it lists that trace ID as the trace ID and lists that span ID as the parent for any subsequent spans that are generated. So we create the first trace ID, we create the second trace ID, we get all of the supporting information that we need, and then we add this information to the trace parent header on the client, and we make a request. We say, give me the to-do by ID. We make sure we got a success status code back. Then we remove the trace parent header and we add it back in, but this time with the second trace ID information, and we make the request again. Now, the expected behavior, of course, as we mentioned already, is the first request hits the database, the second request hits cache and doesn't touch the database. So how can we verify that information? Well, using OddDotNet, the first thing that we're going to do is create a span query request builder. You can do this manually, and in fact, in other languages, you're going to have to right now because the span query request builder is not available in other languages. That's part of the OddDotNet.client NuGet package. But making this builder available in other languages is on the roadmap. I plan on starting with Java and probably Go as the next languages. Anyway, create the request builder. The first thing we instruct it to do is take everything. So for all of the spans that come in, if the span matches the filters that we provide, return that span to us. We want to wait for up to 1 second. So we're saying from the time we initialize the query, there may be some spans that are still hanging out there that our application hasn't sent in yet. So we're going to wait 1 second for all of those spans to come in before we return the results back. And then we've got this where section here. You can add filters, and each filter that's added within this where section is ANDed with any other filters that are added there. So if you add two filters, it'll say if this filter is true and this filter is true, then that span matches all of the filters, and that span is going to be returned as part of the request. In this particular scenario, I'm demoing the OR filter, because in certain situations you don't want to do ands. Maybe you want to say if this span is present or this span is present, return all of those. So this OR filter allows me, just like with the and filters, I can add more filters. And in this case, I'm adding a trace ID filter, and I'm passing in the first trace ID as part of this filter and saying, give me anything where the trace ID equals this first trace ID. And then I do the second thing with the second trace ID. Give me anything that equals the second trace ID. And so any spans, any spans that come into OddDotNet that are collected by the collector will match if they match one of these two filters. There's lots of additional filters that are available. I think I had mentioned earlier, maybe it's on the website, there's about 25 properties that a span has if you include the data for the span, the data for the resource that the span is associated with, and then the data for the instrumentation scope that created the span. And all of those are available. If you take a look here, you can do trace IDs, you can do attributes, you can do flags, really anything that shows up on a span can be searched for as part of a query. Once we've done that, oops, we build the query. So this just puts everything together for us so that we don't have to do it ourselves. And then we call this query async method on the span query service client. And query async, we pass in the request, and of course we get a span query response back. Once we get the span query response back, the first thing that I do here is I split it up into spans where the trace ID matches the first trace ID and spans where the trace ID matches the second trace ID. Then I also define this thing that I'm looking for, the string I'm looking for, which is the instrumentation scope name. In this particular case, I know that this resource is hitting the database, and I know that it's using Entity Framework Core to hit the database. So I'm going to search for an instrumentation scope name of OpenTelemetry.instrumentation.entity framework core, since that's the library that was used to generate the span. And then the last step in the process here is I assert that the first request spans contain that instrumentation scope name, that they have a span indicating that the database was hit. And then the second assertion here is making sure that the second trace does not contain anything related to OpenTelemetry instrumentation entity framework core. Let me go ahead and run this. I'm going to do a debug real quick just so you can see the results that are coming back. And first step in the process, of course, when you're doing debug with a .NET Aspire application is it'll spin up the application itself. That's the to-do web app right there. And then I have the test over here. And it also spins up the container. I don't have a way to show you that right now, but spins up the container, the OddDotNet container as well, and configures everything there. So if we take a look at the response that's coming back, you can see this span query request. That's important to see that. Let's take a look at the request here. So it has a take property with a take all. It has a duration property that says how long to wait. And then it has all of the where span filters that can be used as part of the request. In this case, it's just a single filter, which is the OR filter. But then if you take a look at that span OR filter, it also has a list of filters, which are the two that we added to search for the different traces. So there's the request, and then the response that comes back, this span query response, you'll see it has 3 spans, and those 3 spans are the same 3 spans that we saw in those 2 GET requests in the dashboard that we were looking at earlier. The first 2 of these, you'll see they have a matching trace ID. So these indicate the database hit. That's that span right there. There's the OpenTelemetry Entity Framework Core message. And then this other span that has the different trace ID down here, it's a single one. This instrumentation scope is just ASP.NET Core. That's just the HTTP request that's being generated. That is kind of a brief overview of how to use the OddDotNet client and the query service to be able to obtain your traces. So now that we've gone over the demo, I wanted to talk a little bit about the roadmap, just go over what's coming up next for the project. Currently, traces are in active development. The version as of the time of recording of this video is 0.1.0. Once I feel that traces are ready to be released, they're stable enough for production use, I'll bump that version number up to 1.0.0. I'm also planning on getting Java and Go clients in place here soon. And if there's interest in other languages like Python or something like that, let me know in the GitHub discussions. I can see what the interest is for those languages and then develop some clients for those as well. Metrics, I think, is going to be next. I haven't started that yet, but I'm going to most likely do a version 2.0 for metrics and then version 3 for log records. As far as the education piece goes, I plan on shooting YouTube videos, I think every 2 weeks, with new content, new examples that outline a different feature of the project, different capability. And then I'm also making website and documentation updates on an ongoing basis as I make changes to the project. It's just me working on this, so I'm stretched between doing the development work and the website maintenance, and then also the YouTube videos. So bear with me as I work on getting this stuff put out. And lastly, help and support. If you have questions, comments, requests for different languages, if you need to know how a particular feature works, of course you can go to the website, or if you have questions you'd like to get answered, feel free to toss those in the GitHub discussions page under the main OddDotNet repository. I'll post a link to that below. I'm also in the process of getting a Discord server set up. I have created it. I just don't have everything in place yet. So once that's finished, I'll get that information loaded onto the website under the Contact Us section as well. All right, I think that's everything. Thank you for watching the video, and we'll see you next time.